Let's try to find the domain and range of different type of functions. First, we have linear functions. They are in the form of y equals ax plus b. The highest exponent of the variable in a linear function is 1, so you will not see any squared, cube, or square root. And the graph of a linear function is a line. Example here, the red line, y equals 1/2 x plus 2, and the blue line, y equals negative x plus 5. So in general, the domain and range of linear functions are all real numbers. Next, we have quadratic functions with the general form y equals ax squared plus bx plus c, where a is not equal to 0. Here, whatever the value of our x, the function is always defined. Thus, the domain of the quadratic function is all real numbers. Next, the graph of a quadratic function is a parabola that either opens upward or downward. And it is necessary to determine the opening of the parabola to find the range. So how would you know if it opens upward or downward? Take note of the leading coefficient or the coefficient of x squared. If it is positive, then it opens upward. Take a look at this example. The leading coefficient here is positive 1. That's why the graph opens upward. We can easily determine the range by simply looking at the graph, but what if there is no graph? So here's the formula that you can use. Y greater than or equal to f of negative b over 2a. Let's check if this formula works. In the given function, f of x equals x squared minus 4x plus 5, our a is equal to 1, our b is equal to negative 4. In that case, negative b over 2a is equal to negative of negative 4 divided by 2 times 1, which is equal to 2. So, f of 2 is equal to 2 squared minus 4 times 2 plus 5, which will give us 1. Therefore, the range would be all values of your y such that y is greater than or equal to 1. Let's have another example. Y equals x squared plus 4x plus 3. First, the domain would be all real numbers. Then, the leading coefficient is positive, then it opens upward. To solve for the range, a is equal to 1, b is equal to 4. So, negative b over 2a is equal to negative 4 divided by 2 times 1, which is equal to negative 2. F of negative 2 is equal to negative 2 squared plus 4 times negative 2 plus 3, which gives us negative 1. Therefore, the range would be all values of y such that y is greater than or equal to negative 1. Let's check the graph if our answer is correct. Now, let's try to look at parabola that opens downward. This happens when the leading coefficient is negative. Take a look at this example here. The leading coefficient is negative 1. That's why the graph opens downward. The domain is still all real numbers, but for the range, we will use the formula y is less than f of negative b over 2a. Let's use the formula to the given function g of x equals negative x squared minus 6x minus 5. Where our a is equal to negative 1, our b is negative 6. Solving for negative b over 2a, we have negative of negative 6 divided by 2 times negative 1, which will give us negative 3. Solving for f of negative 3, we have f of negative 3 equals 4. So the range would be all values of your y such that y is less than or equal to 4, which is clearly shown in the graph. Let's try another example. Y equals negative x squared plus 2x plus 2. The leading coefficient here is negative, so the graph opens downward. So the domain would be all real numbers. And for the range, a is equal to negative 1, b is equal to 2. So negative b over 2a is equal to 1. And solving for f of 1, we have f of 1 is equal to 3. Therefore, The range would be all values of your y such that y is less than or equal to 3. Let's check the graph to verify our answer. Next, we have radical functions. For radicals, we have to make sure that the radicand is greater than or equal to 0 if our index is even, like square root, fourth root, to avoid getting imaginary numbers. If it is odd, like cube root, fifth root, then nothing to worry because the function will always be defined. Let's try this example. The square root of x plus 2. To find the domain, we have to make sure that x plus 2 is greater than or equal to 0. So x should be greater than or equal to negative 2. Therefore, the domain would be all values of x such that x is greater than or equal to negative 2. Since negative 2 is the smallest possible value of x, our range would be all values of your y such that y is greater than or equal to 0. Let's check the graph to verify our answer. Here is another example. G of x is the cube root of x plus 2. But since the index is odd, the cube root, then the domain and range would be all real numbers. Let's check the graph. Next, we have rational functions. They are in the form of p of x over q of x, where q of x should not be equal to 0. Obviously, they are in a fraction form, so we have to make sure that the denominator is not 0. And the values where the denominator is 0 will not be included in the domain. As for the range, the best way is to find the domain of its inverse or by looking at its graph. So let's have this example. H of x is equal to 5 over x minus 2. To find the domain, let's equate the denominator to 0. Solve for x, so x is equal to 2. This means that x cannot be equal to 2. Therefore, the domain is all values of x such that x is not equal to 2. And the range of this function is all values of y such that y is not equal to 0. Let's check the graph. Here is another example. H of x equals 2x over x plus 3. First, equate x plus 3 to 0. Solve for x, so we have x is equal to negative 3. This would mean that our domain would be all values of x such that x is not equal to negative 3. As for the range, let's check the graph. If you notice, the graph is asymptotic to y equals 2. Then, our range would be all values of y such that y is not equal to 2. Last example, h of x is equal to x cubed over 2x minus 5. Again, equate the denominator 2x minus 5 to 0. Solve for x. X is equal to 5 over 2. Then our domain would be all values of x such that x is not equal to 5 over 2. Checking the graph of this function, the range would be all real numbers.